So now that we have a way to basically take all the features that we had, we needed, and to generate them, so to send them across with sensible sizes, the goal is now to create a payout, so the logic for our investment algorithm to use this data and to invest. There are many ways in which you could do that. I'm just going to illustrate a couple of them here. So you could do what I have chosen, and I will show how to do, is to use a fixed training window. So as we said, we are feeding batch after batch. So basically the blue side here is a batch. Then I will do some computations. Basically I will try to predict all the other points, and then I'll receive a new batch, and then I'll predict all the future points, and then I'll receive a new batch. So this is basically independent batches that we receive one by one. You could think of other ways to do this. For example, here you can use a constant window, so that's just gradually increasing the basically rolling forward, but with the same length of the window here, and you're only predicting one point at a time. Or you could use an expanding window, starting with just a few points on the left, and then keeping the whole history as you go through time. So that's different ways, and you need to test and try them out to know which one works best for what you want to do. In my case, I'm going to use the first one, the fixed training window, so that I can feed batch after batch, and my payout will read and learn from this batch, and then predict a series of prices. Sorry, up. So as we said, we're receiving batch after batch. So this is what I'm taking in my payout in my model. I'm getting a data generator. Target will be basically which series I'm trying to invest in, and then forecast horizon is just the way I'm doing labeling. For those that want to learn a bit more about that, please watch the replay of last webinar. But roughly, I'm doing classification here, so I'm just trying to predict plus ones and minus ones, and to basically generate my initial classes or targets in a supervised learning model. I am using 62 or 3 months trends, and say if the trend is positive, then it's going to be a 1. If the trend is negative, then it's going to be a -1. So this forecast horizon determines the period over how much I'm going to try and determine if it's an uptrend or a downtrend. So if we dig into it, we are correctly getting our data generator. Again, we are calling it with brackets so that we are getting the first batch here. This is only to initialize the output, so just giving me a placeholder to be able to append my predictions after my model has done some predictions. So let's skip that. And this is really, so usually in machine learning it's called the training loop, but you see that there is a while, and we want our generator here to not be a character or string class or character class, because remember, when the generator is exhausted, then I receive something, a message that is a string message that the iterator is exhausted. So I am going to keep on receiving data until I receive that message, basically. So here I am keeping the logic within my loop. I am getting the batch number and the data from my generator. Why do I request the batch number? It's because I have here an argument called retrain every n batches, n batch, and that's telling me that every 2 batch I am going to retrain my model. So we'll see that in the training loop. Here, the labeling, I'm just generating the label, sorry, for my model. It's the same rough technique that I've used in the previous webinar. I'm just taking the trend, as I just said before, and then I'm just combining my data to the labels so that I get a set with data and labels. The training starts really here at line 104, and the reason why here I was taking the batch number was because I'm doing discrimination between if it's the first batch or if it's train every n batch. So if we go down a bit, this is not very important. What is important is here I'm training an XGBoost model, and the XGBoost model is basically going to retrain. That's why I've written continue training. It's going to retrain every n batches. So every 2 batches is going to retrain. How do we do that in XGBoost? Here, that's the key line. It's taking the same model that I've generated before, and it's training on top of it. We'll illustrate that slightly later, but the idea is not to lose the benefit of what we've learned in the past. If obviously you retrain from scratch every time, then you're losing anything that you've seen in the past. The flip side of that is to try and not overfit, but that's a trade-off that you want to think about. So when it's train or retrain, then that's pretty classic. I'm predicting with my model on either the points that were left. If I go back here, this point here, but actually I'm not retraining every batch. So here that would be every batch I'm retraining. So if you get rid of this blue square here, basically I'm receiving here, and every 2 batch I'm receiving another batch here. So I'm predicting all across, even if I don't receive the middle batch. And then once I've done my predictions, I'm calling my next batch at the end of the training loop, and then it's starting again within this loop. So if I run that and I generate a new generator, because just to make sure we start at the starting point, and we are running the payout on the data on the generator, trying to predict the Brazilian stock market, and again taking 3 months trends. We're just going to do this, and here it's interesting because you see the training. So I've put the dates at which it starts training and stops training. So as I said in the question of Otman, the first batch is larger than the other batches, so it's from 2010 to 2013, whilst the other ones are only 1 year batches. However, as I am retraining and keeping here my model, it's not only 1 year of data, it's the previous model that is being fine-tuned over 1 year of data. And you can see here that it starts at 1, it does 2000 epoch, and then rather than starting again at 1, it's starting from epoch 2001, and then retraining again for 2000 epoch, and then again starting at epoch 4000, and then doing 2000 epoch more. So this is pretty much the behavior I wanted to show, and from this we can just dump the model here in our backtesting engine, and we see we're doing pretty good compared to the underlying asset, which is the Brazilian stock index. We see that here, for example, we have correctly switched to short, which has helped us greatly at this peak, and we have slightly more trouble here to be long, but the market is doing nothing. Well, anyway, so that's the result we get, which is not too bad. and you can play around with the loopback period and the batch sizes to see which retraining frequency helps your model most, and how the basically the model behaves when you're tweaking them to a shorter period or to a longer period. My point here is just make sure that whenever you train, you keep what you have trained before, and then train on top of what was done. So that's pretty much it for the code I wanted to show you. So just as a summary, we regenerated the features, but this time rather than going through the whole code, we can just only use one function, get series feature. Then we did a data generator functions that is going to give us back batch sizes. You can directly copy that function and adapt it to your needs. There's no problem with that. No need to reinvent the wheel. And then from these two elements, we have built a payout which is correctly looping through the generator, basically, in order to train and then retrain the gradient boosting model in order to give us our predictions. And from there, we could basically backtest the strategy against the Brazilian stock market and had decent results. So this is all for me. Thanks for listening to me, and hopefully you enjoyed it. Let's open the floor, please, to Q&A.